In this video, I will show you a simple Python program that will collect data from SenseHead and save the results into a SQLite database table. This program will perform very basic functions, although Python can do a lot more. With the help of a system tool, I will schedule to run this program repeatedly at a fixed interval of time. I will let the program to run for a couple of days. Then I will examine the data collected. Here is the system configuration that I use for development. I have a SenseHead mounted on the Raspberry Pi. I will be using Visual Studio Code for programming with Python and SQLite extension. I will also be using SQLite and SenseHead libraries for Python. Except for SenseHead library, you can find the installation instructions of the software in my earlier videos. This is the image of a SenseHead mounted on the Raspberry Pi. Let me begin to create a folder for the project. I will name the folder SenseHead. Next, I will create an empty SQLite database called sensor.db. Now in Visual Studio Code, I will open the folder SenseHead. Click on Explorer icon. Select SenseHead folder. This is the source code to create the SQLite table sensor log. There are 3 columns in this table: temperature, humidity, and log time. Please note that Raspberry Pi relies on internet connection to synchronize time. If there is no internet available, you will need to enter date and time manually, or you can install a battery-powered date-time module on your Raspberry Pi. Let me run a query to create the table. The table is created. The Python program is named sensorlog.py. This is the program that will log the sensor data into the database table. It is quite straightforward. Let me walk you through the source code. The first part is to get the sensor data with SenseHead library. I am saving the results in variables. Following is the SQL statement that will insert a row into the table. Notice that I'm using question marks as placeholder for the values. This part of the program is to save the data into SQLite table. I'm using the full path for the database file because this program will not always be running from this folder. It is important to commit the transaction and close the connection. At the end, I print out the data. The blinking LED tells me the program is still running properly if there is no monitor connected. After testing the program, I'm ready to set up a schedule to run this program. I'm using command cron tab to schedule the job. If this is the first time you use the command, you will be prompted to choose an editor. I had already chosen Nano earlier. Scroll down to the last line and enter the task to be scheduled. Save the file and that's it. I'm going to leave the Raspberry Pi to run for a couple of days and come back with the results. 2 days has passed. Let me turn off the schedule. I'm changing the line to a comment. Then save the file again. Let's run some queries on the table. I need a little more room on the screen. How many rows are there? It shows 286. Last 20 records. Notice the temperature is high. That is because the sense head is mounted very close to the CPU. The heat from the CPU raised the temperature. To get a more accurate temperature, you need to connect the sense head with a cable and move away from the CPU. The begin time and the end time. How many rows are there in a given date? Some statistics about temperature. And for humidity. When is the minimum temperature occurred? It's 4:50 a.m. And when is the highest temperature occurred? Sometime in the afternoon. That's it for this video. See you next time.